So today we're going to look at another method of solving a system of equations called substitution. And in the context, there are a lot of different ways that we can solve systems of equations. We've already talked about graphing. Today we're going to talk about substitution, and eventually we'll talk about the third method of elimination. What I think is important for today, though, is just kind of setting the stage. When we talk about substitution, our overall goal is to take a system that has more than one variable and rewrite it in a way that only uses one. Then we can solve it by hand rather than making a graph. We can just do regular algebra on it. So just a few things to touch base about that'll help us understand this method a little bit better. During the introduction to the unit on the system of equations, we were discussing the idea that we can only solve for as many variables as we have equations. So like my first example here, we can clearly see that there's one equation. It's this equation here, 3 equals 2x plus 6, and there's only one variable, and that variable is x. So I can solve for that. I will be able to find the specific value of x. So let's just go ahead and quickly do that. So if I wanted to get x alone, I'd subtract 6 first. So I get negative 3 is equal to 2x. Then I want x multiplied by 2, so I'd undo that by dividing. So I get the value negative 3 halves is equal to x. So again, the number of equations matched the number of variables, 1 and 1, so I was able to find the specific value of x. In a different situation that I have here, if I have one equation, so again we can see that we're just given one equation here, y equals 2x plus 6, but it has two variables. One of them is x, and one of them is y. Because the number of variables doesn't match the number of equations, we won't be able to find the specific value of x or y. So like for example, I already know what y is. Y is equal to 2x plus 6. There's no other way for me to tell you what y is because I don't know what x is. So I can't tell you the specific number for y. If I tried to rearrange the equation to get x alone, like by subtracting 6 first from both sides, and then dividing everything by 2, I can get x alone, but I can't tell you the specific number it's equal to because it has that variable y in there. So if we have one equation, we can't get a specific value if there's two variables. If we have one equation, we can get a specific value if there's only one variable. So that brings up the important idea that if we have an equation that just has two variables in it, if we could somehow rewrite it so it only uses one, then we'd be able to solve it. So before we get to that though, we just want to touch base about the idea of an equal sign. And this is super important, as you can see that I'm labeling here. This is super important to our understanding of the substitution method. So the idea of substitution, we already know one really, I guess, positive way of using it, and that's just saying that values are the same. So for instance, 4 plus 1 is the same thing as 5. So sometimes we see the equal sign as these numbers are the same. They have the same value. So I could do something like 3 plus 5 is the same value as 8. Another one would be like 4 over 1 is the same value as 4. We're familiar with that understanding of the equal sign. What's more important for our work today is seeing that equal sign as I can replace these things. So in other words, what it's telling us is whatever I see on the left side, wherever I see this symbol, y, I can replace it with these symbols, 3x plus 6. So see the equal sign as what you can replace. So then using that idea, again, I'm just copying this over from the last slide, we can see the equal sign as wherever I see the symbol on the left, so again, wherever I see this symbol, that y, I can replace it with this other symbol, 3x plus 6. So we're just going to practice that really quick. So if they tell us down here that y, so this symbol can be replaced, and again, I want you to see that equal sign as can be replaced by these other symbols, 3x plus 6. So when I'm going down to rewrite something, wherever I see that y symbol, so I see that y symbol there, and I see that y symbol there, I can replace those with these other symbols, 3x plus 6. Now down here there was a plus and a 2. I'm not replacing that. And since there's a 2 in front of it, I'm going to put it in parentheses, but 3x plus 6, and then we had this plus x. So again, that's our basis of substitution. The equal sign tells us wherever we see the symbol on the left, we can replace it with the symbols on the right, so which is what we did. The symbol on the left was a y, so wherever we saw that y, we replaced it with these other symbols, 3x plus 6. So now we're ready to actually do a few problems about solving a system with substitution. And again, our goal is to rewrite the system so that an equation only has one variable. Because if we have one equation with one variable, we can solve it. So our goal here will be to do that first. The first thing we want to do is to be able to rewrite an equation so that it only uses one variable. So rather than using x's and y, it's only going to use just x's or just y's. So we get a variable alone, and what we're going to do with that variable is we're going to substitute it into the other expression. So then the second equation should now only have one variable. So then we can solve the second equation and get the answer for one of our variables. And once we have the answer for one of our variables, we can plug that in to the other equation and get the second variable. So let's see that in practice. It's a little easier to follow along. So I've copied the directions from the last slide here, so to solve a system. So they've given us this system here, and what we can see is that each equation has two variables in it. So I can't solve one equation and get x equals 7 or something like that, because both of these equations have two variables in them. So what we want to do is we want to rewrite one of the equations so we isolate one variable all by itself. So for this example, I'm just going to take the first equation. Now when I look at the first equation, x plus y equals 6, I want to get one of those variables alone. So if I have x plus y equals 6, it doesn't really matter which one I get alone right now, so I'm going to choose to get x alone. So if I wanted to get x alone, I could just subtract y from both sides. So I get x is equal to 6 minus y. So now we have that interpretation of the equal sign. Wherever I see this symbol, I can replace it these symbols, the 6 minus y. So we've done the first step. We rewrote one equation, so it's in terms of just one variable. So x is 6 minus y. So what we're going to do now is we're going to substitute that expression. So wherever we see x, we're going to substitute it into this other equation. So we have 2x minus y is equal to 9. But again, what we just did down here was we gave ourselves permission to say wherever we see this symbol x, so let's go ahead and find that symbol x. Let's just highlight that symbol x. So wherever we see that symbol x, we can replace it with these other symbols, 6 minus y. So I'm going to rewrite the original equation that we're working with, 2, but instead of x, I'm going to replace it with the symbols 6 minus y. And now this equation here only has y's. So we have one equation with one variable, so we're able to solve for that. So we're just going to finish our solving, so we'll distribute the 2. So we have 12 minus 2y minus y is equal to 9. So we'll collect our like terms. So that's negative 3y's is equal to 9. We'll get y alone by subtracting 12. And then our final step to undo the multiplication would be to divide by negative 3. So we get y is equal to 1. So what we have successfully done is we've solved one of the equations for that one variable that we isolated. So we got y alone and we solved for y. So now our last step is just to plug that value of y right here, this y value. Wherever I see y, I can replace it with 1. I need to go back and put it in the other equation. So the first equation we started with, we go back to that. It was x plus y is equal to 6. Well, we know what y is. Y is equal to 1. So if I plug in 1, I'm able to get x alone. So I found x and y. So the solution to our system, the x value is 5, the y value is 1. So this is our solution. Another example that's important to look at here, we have the system x equals 6y minus 7 and 4x plus y is equal to negative 3. Now if we're looking at our steps here, the first step is to rewrite one of the given equations so it has one variable all alone. But what we see is that first one already has x all alone. So we're actually done with that first step right away because x is alone. So we can move on to step number 2 right away. We don't need to isolate x or y because it's already done for us. So what we're going to do then is we're going to take the second equation And again, this tells us here, wherever I see this symbol x, so I see that symbol x right here, I can replace it with these symbols, 6y minus 7. So in the original problem here, instead of x, I'm going to replace that with 6y minus 7. So now again, the second equation used to have x's and y's, but now it only has y's. So we can solve this equation for y. And what we'll see, if we collect like terms, we have 25y minus 28 is equal to negative 3. So if we add 28 to both sides, we get 25y is equal to 25. So then therefore y would be equal to 1. So we substituted and we solved that equation for the one variable it had, which was y. So now what we're going to do is we're going to plug that variable back into the other equation that we didn't use. So we used this one to solve for y, so we're going to use the other one to solve for x. And it tells us that if I want to find x, the x value is equal to 6y minus 7. And I know what the y value is, we just found it to be 1. So I'm going to plug that in for y. So I get x is equal to 6 minus 7, or in other words, x is equal to negative 1. So our solution, the x value is negative 1, the y value is 1, so this is the answer to the system of equations. The last example I bring up is important because here we can see that none of the variables have, or none of the equations have a variable all by itself. Here x and y are on the same side. In this equation here, x and y are also on the same side. So in step number 1, when we need to choose which equation we want to rewrite, the main idea here is which one's easiest to get a variable alone. So I'm thinking about this one. I'm going to have to subtract either 3y or 2x and then do some sort of division. But here, I can get y alone just by adding 6 x's to both sides. So when you're trying to get a variable alone, it does not matter which one you get alone, whatever one is easiest. So here, I rewrote this equation like this. So now that y value is alone. So what I'm going to do is I'm going to go to the first equation, and wherever I saw y, I'm going to replace it with 6x minus 7. And after I do that step, this equation should now only have one variable. And I see that it only has x's, so I know I'm on the right track, and if I have one variable in one equation, then I can solve for it. So if I plug in 20x equals 25, so I get x equals 25 over 20, which will reduce to 5 over 4. Once I have x, I'm going to plug it into the other equation that I did not use yet, which was the 6x plus y equals negative 7. So we're going to go ahead and plug that in. So negative 6, and x was negative 5/4, plus y is equal to negative 7. So I get negative 30 over 4 plus y is equal to negative 7. So I'm going to sweep the fractions away just because I don't want to deal with the fractions. I'm going to multiply everything by 4 to get rid of those fractions. So I get negative 30 plus 4y is equal to negative 28. So I add 30, so I get 4y is equal to 2. So if I divide by 4, I get y is equal to 1/2. So we found x and we found y. So the solution to this system of equations, the x value is 5/4. The y value was 1/2. So this is our solution.